When drawing the first 10 hydrocarbons in the alkane series, what I've done is I've set up a chart like this, and I'd like you to do the same in your notebook, where you have name, molecular formula, structural diagram, condensed, and line. I'm going to take you through an example of a few of these, and hopefully you'll start to see a little bit of a pattern. So as we saw or heard in the messaging on this slide, there is a mnemonic device that allows you to remember the first 4 hydrocarbons: meth, eth, prop, and bute. The rest of these prefixes follow the Latin convention that you would know from previous years. So pent, hex, hept, oct, non, and dec. So let's start off with meth. And because we're doing all single bonds end in ane. So A-N-E, methane. What I'm going to do is draw the structural diagram, and then I'll come back to the molecular formula. So a structural diagram, here is carbon, and we know that carbon has 4 single valence electrons. So that means that it must pair up 4 times. It must fulfill those 4 links. And because they're all single bonds, what I'm going to do is put a bond, and we're going to link hydrogens to the end of those. Okay? Now, there is no condensed structure or line diagram for methane. When I do the molecular diagram, I see that there's 1 carbon, 4 hydrogens. So the formula is going to be CH4. The next one is ethane. Ethane has 2 carbons. So I'm going to draw 2 carbons side by side, and then I will fulfill the number of hydrogens needed to make sure that each carbon has 4 links. 1 link is already between the carbon-carbon atoms, so this carbon only requires 3 hydrogens, and this carbon requires 3 hydrogens. So I'm just going to leave the dashes there, and we're going to assume that those hydrogens are there. So the formula here is that it took 2 carbons and a total of 6 hydrogens to make that hydrocarbon. The condensed version is what we do is we take a look at this carbon and we see that it has 3 hydrogens. So we write CH3 linked to CH3. Now, this gives a bit of a false illusion that this hydrogen is linked to the carbon, when in fact it's the carbon linked to the carbon with the hydrogens situated around. So don't be fooled by that. In terms of a line structure for ethane, what you would do is you would just have a dot, which represents 1 carbon linked to another carbon. And so it's essentially just a straight line, which I know seems a little bit odd right now, but we'll see how this works moving forward. So I'll do a couple more. So propane, prop means 3. So 3 carbons, 1, 2, 3, you link them all linearly. And then what I do is I go in and I fill the required number of hydrogens so that each carbon has 4 links in total. Notice that the central carbon here only needs 2 hydrogens. So when I go to do the condensed version, I take a look, oh, this carbon here has 3. It's bonded to a carbon that only has 2, which is then bonded to a carbon that has 3 hydrogens. When I go to do the line structure, when you have a dot here, that represents 1 carbon, then we have another carbon, and then we must sort of keep going up and down in a zigzag fashion. So every time you come to a point, that point represents a carbon. So 1, 2, 3. Notice in these line structures, you do not need to put in any hydrogens. They are assumed to be there. When I go back to do the molecular formula, I see that we have 3 carbons in total, 1, 2, 3, 4, 5, 6, 7, 8, and 8 hydrogens. Not sure if you are noticing a pattern here, okay? In terms of when we increase the number of carbons by 1, what happens to the number of hydrogens? I'll do one more with you. Let's take a look at 6. So 6 is hex, and I'm going to write down ane at the end. What we'll do is we'll draw 6 carbons in a row. 1, 2, 3, 4, 5, 6. We're going to fill in the remainder hydrogens. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So we have C6H14. When I do the condensed version, I'm going to take a look at this first carbon, and we see that that is a CH3. Now, I notice that I have a whole bunch of CH2s in the middle. 1, 2, 3, 4 of them, in fact. So 4 carbons, each bonded to 2 hydrogens. I could draw each one out doing, CH2 bonded to a CH2, etc. Or what I could do is I could say that with a bracket, CH2 in the middle, there are 4 of those. So I put a bracket around the CH2 bracket with a 4 linked to the ending CH3. So this would be a condensed version of this structure here, or like I said, you could draw out those 4 CH2s in the middle. The line structure, we start with the dot, 1 carbon, 2 carbon, and I keep going up, down, 3 carbon, 4 carbon, 5 carbon, 6 carbon, and I stop. So there's 1, 2, 3, 4, 5, 6 points indicating that is the structure for hexane. So what I'd like you to do is make sure that you can draw the first 10 hydrocarbons in the homologous series. Make sure that you're able to do the structural diagrams, the condensed and the line structures for those, and then please check your answers with the link on the slide.